Hi, everybody. We're going to do a quick lesson here about writing ionic formulas. You may be familiar with this from previous science classes, so I'm not going to spend a lot of time on it. I will give you a little background, do some examples, have you do a few examples, and if you have further questions, please do not hesitate to contact me before you try the assignment. Basically, when you get an ionic compound's name, the positive ion is always going to be the first one in the name, okay? So the positive ion is always first and the negative ion is always second. And we will go and review the periodic table and the ion charges that are associated with those main block elements. If it's not a main block element, you will be able to find the ion charges on the table that I sent to you, and I'll go over some of that in a minute. What you do then is you use the charges of the two ions and you find the least common multiple of those ion charges. That way, if you know, for example, that you have a +3 and a -2 ion, the least common multiple is 6. You try to use the right number of ions to get +6 and -6 so that they cancel each other out, because the overall charge for an ionic compound has to be 0, even though it's made of charged particles. Once you have figured out how many of each ion you need, then you write the formula. And so let's get started and let's practice doing that. Remember, this is the little review here, that the alkaline metals make +1 ions, the alkaline earth metals make +2 ions. Boron is not going to readily make ions, but from aluminum on down, the elements in this column tend to make +3 ions. I did not give you a rule for the carbon column. Carbon, silicon, and germanium tend to not really make ions, and tin and lead make two different ions. They make a +2 or a +4, and I'll show you how we handle that in a minute. Then you're kind of in the nonmetals, where instead of losing electrons, they tend to gain electrons to make ions. For example, the nitrogen column, they tend to make -3 ions. Remember the oxygen column, -2, the halogens, -1. And the noble gases, we didn't assign them an ion charge because they have a full outer shell. They tend not to gain or lose electrons when making, they don't make ions. I shouldn't say when making ions. They don't make ions. They don't need to gain or lose. So when you write the formula, you really need to look like magnesium and chlorine. Now, the second element is always going to have its ending changed to IDE. So you look, for example, here's magnesium, and here's the chlorine, and when it gains the electron, then they call it chloride. So we know that magnesium is a +2 ion, and then we know that the chloride is a -1 ion. Wow, I'm getting lots of little offshoots. But once you know that the least common multiple of 2 and 1 is 2. So to get a total of +2, we only need 1 magnesium. To get a total of -2, we need 2 of the chloride ions. And this makes sense because magnesium has to give away 2 electrons, and each chlorine can only take 1. So we need 2 chlorines for every 1 magnesium, because every electron that is lost has to be picked up somewhere. So this is the formula for magnesium chloride. So looking at the other one, we had, and I just forgot, aluminum and oxygen. So aluminum is +3 and the oxide is -2. So if aluminum makes a +3 ion and the oxide makes a -2 ion, the least common multiple of 3 and 2 is 6. So I need 2 aluminum ions to have a total of +6. I need 3 oxide ions to have a total of -6. And this is the formula then for aluminum oxide. Whenever it's a 1, like right up here, we don't write that. We just put no subscript and assume that it is a 1. If you are going to, on the worksheet, write these by hand, then you can certainly, You can certainly write this easily by hand, but if you are going to be typing these, you need to make sure that you highlight and subscript the numbers in the formula because they are indeed subscripts. So try these, pause the video, try them. When you're done, restart the video. Okay, hopefully you just restarted the video. And these are the ions that are going to make up these two compounds. Now, the potassium and the nitrogen, nitride is the nitrogen ion you can find in the main block elements, and same with the bromine. The lead, we didn't really assign a rule. Well, we're going to see that on the ion chart that contains all the like transition elements and some of the ones that we don't have rules for, if there's more than one possible charge, this Roman numeral here tells you what charge to use, okay? So lead could be +2 or it could be +4. So we use the lead +4 because of the Roman numeral 4. Using these ions, we need 3 potassiums for every 1 nitride. And we need 1 lead for every 4 bromines. Questions, make sure you get in touch with me. Okay. Now, what about those ion charts that you have that I sent to you? Well, you remember there's like that whole area in the middle of the table, the D and the F block, where they're not part of the main block, and we didn't assign charges. And then there was also tin and lead. We didn't assign a charge to those. These are the cations that we couldn't really assign a rule, okay? And so the ones that are not in bold, like if you look on your table, zinc is not in bold. They only form one possible stable ion. So we just call their ion by the name of the element, like Zn+2 is called zinc. But if they are in bold, that means that they form more than one possible stable ion, and they must have a Roman numeral in the name. So that's why on the last one, when we saw the Roman numeral 4, we used the lead +4. Here, for example, you can see the Roman numeral 1 is the copper with the +1 charge, and the Roman numeral 2 is the copper with the +2 charge. They will form different ratios with other ions when making a compound. And often these different ratios make very different compounds with very different properties. So it's really important that you know which one to use when writing the formula. So let's try then, oh, I forgot, the anions, okay? The anions are at the bottom half of the chart. Now, there's a lot of anions that are groups of atoms bonded together that as a group, they carry a charge. These are called polyatomic ions. Now, most of them are negative. There is, however, one polyatomic cation. Do you see the ammonium in the +1 column? Okay. All of these groups behave just like the nonmetals did, or, in the case of ammonium, the metals. They perform as a group, and you consider their charge as a group when you're writing their formula. You got to be really careful, though. Like, some of them have an ite or an ate ending, and the only difference is 1 oxygen, with the ites having 1 less oxygen than the ates. Some of them have prefixes, like hypo means 1 less oxygen. So hypobromite is different than bromite by an oxygen, and that's important. Some of them have a prefix per, which they have 1 more oxygen, like perbromate has 1 more oxygen than bromate. It's important that you use the right ion when you're writing these formulas. Let's try a few. So like here, chromium 3, that means that you want to use chromium in the +3 form. Carbonate, you look on the chart, and you find that it's a CO3 group with a -2 charge. Now, this is pretty similar to that aluminum and oxide, where aluminum was +3 and oxide was -2. The least common multiple is 6. I need 2 of the chromium ions and 3 of the carbonate ions. Here's the difference, though. Where I did that aluminum oxide and I just wrote Al2O3, here, because the carbonate is a group, I have to put it in parentheses before I list the 3. So it's still a 2 to 3 ratio of the ions. It's just the carbonate is a group, so I have to put it in parentheses. Okay. Copper in the +2 form. Sulfite, if you look carefully on your chart, is SO3 -2. In this case, +2 -2, I just need 1 of each. If you do not need to double or triple or quadruple the group, then you don't put it in parentheses. Notice I did not put parentheses around my SO3 group because I only needed 1 of them. So try these. Again, pause the video, try them, and then restart to check your answers. So hopefully you have found all of these ions, okay, and tried to write their formulas. Aluminum is the only one that's a main block element. The hydroxide and the nitrite you had to find in the anion section. The zinc, being a transition element, is in the top half of that ion chart. It's not in bold, and it didn't have a Roman numeral because that's the only ion it makes. You do these the same way. Because aluminum is +3, I need 3 of the hydroxides. It is a group, so I must put parentheses and then a 3. Now, I get a lot of people that forget the parentheses with hydroxide because it doesn't end with a number. They just sometimes forget to do that. But do you see the difference between these two? Like here, that's 1 aluminum, 1 oxygen, and 3 hydrogens. But we need 3 of this whole group. And so it's actually wrong to write it without the parentheses. We need the parentheses around the group because we need to triple the entire group, both the oxygen and the hydrogen. The bottom one, we need to double our nitrite group. And a lot of people will remember the parentheses there because it ends in a number. It seems like that kind of clues people, oh yeah, put a parentheses before I put another number. So hopefully you made out okay in writing these. Remember the positive ions first, the negative ions second. You find the least common multiple, figure out how many of each ion you need to make it 0 overall, and then you write the formula. And if you need any help, please see me. I'll be happy to help you out.